Welcome to Miss Smith's Math Tutorials. I'm Miss Smith. In this video, we're going to be talking about adding and subtracting rational expressions. We're going to follow some steps to do that. Our first step is going to be to factor the denominators if possible. Step 2 is going to be to determine the lowest common denominator or the least common denominator, which from now on I'll just refer to as the LCD. So we'll look at how to do that. In step 3, we're going to find any restrictions using that LCD. So we'll talk about that. Restrictions are kind of parameters to say, okay, here's our answer, but X cannot be these things. Then we're going to move to step 4. We're going to multiply all numerators by the LCD. So the LCD is a really important thing to make sure we have right. Step 5 is to cancel any common factors. Step 6, simplify the expression. And step 7, to write your final answer with the LCD in the denominator. That's a really easy step to forget, but it's so important to do. So this video goes hand in hand with the multiplying and dividing rational expressions. So I'll definitely link to that one because these do have a lot of similarities, but adding and subtracting is different from multiplying and dividing. And I think it's a bit harder. We've got more rules attached to it, so we got to be more careful. When we're multiplying and dividing, it's a little easier. Let's think back. We're going to kind of go old school for a second and think, how would we add a fraction to another fraction? The first thing we need to figure out is what is our least common denominator, our LCD. So when we're looking for the LCD of two numbers, we're asking what's the lowest number that both of those numbers multiply into. So we would want to think about, okay, what are the multiples of 4? And what are the multiples of 3? And the lowest number they have in common is our LCD, our least common denominator of 12. We just kind of note that off to the side. And then what we do is we can multiply each of the numerators by the least common denominator of 12. So we'd want to multiply 1 by 12 and 2 by 12. 1 times 12 would just be 12. So we've got 12 over 4. 2 times 12, well, that would be 24 over 3. So our next step would actually be to go ahead and divide these down. Like, what is 12 divided by 4? Well, that would be 3. And then we have our plus. And what is 24 divided by 3? Well, that would be 8. So then we'd want to add those together. So 3 plus 8 would give us 11. And then as our final step, this is that step 7 down here, we always want to write our LCD as the denominator. So we know that 1/4 plus 2/3 is 11 over 12. We would always want to check to see, does 11 over 12 reduce? Is there any number that goes into both 11 and 12 evenly? And there's not, other than 1. So at that point, 11 over 12 is our final answer. You'll find that when we do this with our rational expressions, we're going to follow those exact same steps. Step 1, factor denominators if possible. Looking at this first denominator, x squared plus 5x plus 4, I noticed that that's a quadratic trinomial, so we can definitely try to factor this, and probably the first thing you want to try is to use your x. Remember, x is a times c, which is 4, and then we have our b, which is 5. What multiplies to give me 4 and adds to give me 5? Well, I know they'll both be positive, and it's going to be 4 and 1 as my factors. We've got a numerator of 1 and a denominator of x plus 4, x plus 1. Then we've got our plus sign. Let's think, can I factor this other denominator? Can I factor x plus 1? And you would want to think through it, like, could I do a GCF? Could I do, is it a difference of perfect squares? And it's not. X plus 1 is as low as can be factored. We'll just rewrite that. Now, I always like to write my binomials with parentheses around them because it'll help us see what we can cancel a little bit easier later on. That's just personal preference. You don't have to write parentheses around that one if you don't want to. Okay, so we've done step 1. Step 2 says determine the LCD. So you might be thinking, well, how can we use the calculator for that? Like, how do I figure that out? No, unfortunately, we just have to think through this one. However, it's really pretty easy. We ask 2 questions when we're going to find the LCD when we've got factors like this. We ask ourselves, what do the denominators have in common? And what do they have different? When we look at these 2 denominators, I would say, okay, well, they have in common x plus 1. So that tells me my LCD, which I'm just going to note up here, part of it is going to be x plus 1. Right? That's what they have in common. Now, what do they have different? Well, this one has an x plus 4 and that one does not. So we would say, okay, they have different x plus 4. So now we have our LCD. For our step 3, it says find restrictions using the LCD. When we're finding restrictions, what we're saying is x could not be these certain numbers, because if it was, then we'd end up dividing by 0, which is a big no-no. So here's what we do to figure that out. I like to make like a little restrictions kind of note over here on the side. My restrictions are going to be each part of my LCD set equal to 0 and solved. Let's see what that looks like. Well, the first part is x plus 1. We'll set that equal to 0. And then my second part was x plus 4. So we'll set that equal to 0 as well. Now we want to solve each of these little equations that I wrote for x. So in this first one, I would just subtract 1. And I'd get x equals negative 1. And then in the second one, I'd want to subtract 4. And I'd get x equals, want that to be a subtraction, and I'd get x equals negative 4. What that means, and here's how we write a restriction. We say x cannot equal negative 1 or negative 4. So we're going to use that as part of our answer once we have it. Okay, so we did our little sidebar with our restrictions. Let's jump back in, and we're now at step 4. So multiply all numerators by the LCD. If we can do that, we don't need to rewrite this step necessarily. You can if you want to, but to save time, I'm not going to. I'm going to show this multiplying each of the numerators by the LCD like this. I'm going to do 1 times x plus 1 times x plus 4. And then I'm going to do the same thing to this 5. So 5 times x plus 1, x plus 4. Now step 5 says cancel any common factors. So let's look at what I could cancel. Instead of rewriting this whole thing, I know that there's an x plus 4 here and an x plus 4 there. So I know those two will cancel. I know there's an x plus 1 there and an x plus 1 there, so I know those two will cancel. So all I'm left on this side is just a 1. And now let's do the same thing over here. So I see an x plus 1 and then an x plus 1, so I know those will cancel. And then I can't cancel the x plus 4. There's not one down here. So at that point, I just have left plus 5 times x plus 4. Hopefully you're thinking distribute, because that's what we need to do with that 5. So we've got a 1 plus 5 times x is 5x, and 5 times positive 4 is positive 20. We would then want to combine any like terms. So I see we've got a 1 and a 20 there. We always write the x first, so let's put 5x plus, and then 20 plus 1 is 21. And then now we're ready for number 7, step 7. So it says write your final answer with the LCD in the denominator. So we've done all the simplifying we can do, and now we just put our LCD in the denominator. Remember, the LCD's right up here. We wrote it. X plus 1, x plus 4. And we'll go ahead and like box our answer. Also, just note on the side that x cannot equal negative 1 or negative 4. So again, those restrictions are saying that x cannot be these things, because if I were to plug in negative 1 for x Or if I were to plug in -4 for x, I would end up with a denominator of 0, which we cannot have. Let's look at a second example together. So again, we're going to do another addition problem. We want to follow those same steps. So step 1 is factor the denominators if possible. So when I look at my denominators here and here, I've got a 2 and then I've got an x squared. Neither of those can be factored anymore. They're already in their most simplified form. So we actually, in this case, we get to skip number 1. Step 2 says determine the LCD. So let's go ahead and write LCD and let's figure out what it is. It's always important to make sure you write your LCD out so it's very clear and you can refer back to it as you need to. Looking at my denominators, I have a 2 and I have an x squared. Again, for the LCD, we ask ourselves, what do the denominators have in common and what do they have different? Now in this case, they don't have anything in common. It doesn't look like 2 and then x squared, nothing in common there. They do have some stuff different though, right? This one has a 2 and that one has an x squared. So my LCD is just 2x squared. Now when we move to step 3, find restrictions using the LCD, we'll do like a little restrictions section over here. And remember, we take our LCD and we set it equal to 0. Now in this case, I only have a monomial, right? It's just one term. I don't have 2 factors like I did on the first one. That's fine. In this case, that's 2 times x squared, so we divide by 2. And we'd get x squared equals 0. And then we don't want to know x squared, we just want to know x. So remember, how do we get rid of a square? How do I get rid of a little 2? Well, I take the square root. That gets rid of the 2 and gets rid of the square root so that you just have x. But if you're going to take the square root to one side, you have to do the same thing to the other. Now the square root of 0 is just 0. Our restriction, we only have one in this case, that x cannot equal, put a little star there, x cannot equal 0. So we'll kind of attach that to our answer. Let's jump back into what we're doing up here. We found our restriction, so we want to multiply all of the numerators by the LCD. So we can go ahead and do that with what we already have written. We just want to up here do a little multiplying by 2x squared, multiply by 2x squared. We want to cancel any common factors, step 5. Notice how we have a 2 here in our LCD that we're multiplying, and we have a 2 down here, so we can actually cancel out those 2's. All we're left with on this side is a 3x times an x squared. So we're just going to note that down here. A 3x times an x squared. And then we've got our plus sign, right? And then over here, I've got an x squared in the denominator and an x squared up here. So I can go ahead and cancel the x squared in the LCD and the x squared in the denominator. And now all I'm left with is 2 times x squared plus 5. So 2 times x squared plus 5. And now we're ready for step 6, to simplify the expression. We'd want to multiply here 3x times x squared. Remember that that x has an exponent of 1. And anytime we multiply straight across, we add the exponent. So that's really 1 plus 2. So this ends up being 3x cubed, 3x to the 3rd power. And then we want to distribute this 2 to the parenthesis set. So we have a 2 times x squared is a 2x squared. And a 2 times a positive 5 is a positive 10. At this point, you'd want to see, are there any like terms we can combine or anything? And we cannot. These are all not like terms. So at this point, we've simplified as low as we can go, and we're ready for our step 7, which is write your final answer with the LCD in the denominator, 2x squared. So at that point, this is our answer. But we do want to note the restriction. X cannot equal 0, as we found out over here. I want to point out just one quick thing about that answer before we switch to the next page and do some subtraction. I know it is so tempting to want to cancel right here, because that's a 2x squared and that's a 2x squared, and didn't we cancel stuff up here that was the same? Yes. Here's what we have to realize though. This is held together, that 2x squared is held together to each of these parts through either addition or subtraction. In this case, it's through addition. And when that happens, that means that this is tied to both of these terms. So when you have a term that's tied to another term through either addition or subtraction, you can't just cancel what you want to. If this said 2x squared times 10 and times 3x squared, then we could cancel all day long, no issues. But you just have to be really careful. But I know the temptation is there to just like, oh, let me cancel this and then write my final answer. But just be careful there, okay? So our steps are still going to be the same. Our first step is going to continue to be to factor denominators if possible. So notice here, we can definitely factor both of those. So let's do that just kind of over on the side. For this first one, a times my c is going to be a -2, and my b is going to be a -1. I know my signs would be a negative and a positive, and let's see, that would be a -2 plus 1. So let's rewrite this. So we've got a 2x over x minus 2 from right there, and x plus 1 from right there. And now we'd want to factor the second one. So in this one, let's see, we've got an a times a c of 2 and a b of -3. I know both would be negative, and it would be -2 minus 1. So we've got a 4x over x minus 2, x minus 1. We finished step 1, we factored the denominators as much as we could. Step 2 says to determine the LCD. Remember, our LCD is what do the denominators have in common and what do they have different. Let's note our LCD. What do they have in common? Well, they both have an x minus 2, right? So that's what they have in common. Oops, sorry, or x plus 2. X minus 2. And they both have, oh, no, this one has a plus 1 and that one has a minus 1. So we need to include those. Those are our differences, right? So they have in common x minus 2 and they have different x plus 1 and x minus 1. We have an LCD of 3 different factors. So let's go ahead and do our step 3. Let's find any restrictions and let's note them on the side. So our restrictions. So remember, that's when we take each factor of our LCD. So x minus 2 equals 0. Right, and I put parentheses around that just out of habit. You do not have to by any means. We have an x plus 1 equals 0. And we have an x minus 1 equals 0. So let's solve each of these. For this one, we'd want to add 2 to both sides. So we'd get x equals 2. For this one, we'd want to subtract 1 from both sides, and we'd get x equals -1. And then for this one, we'd want to add 1 to both sides, so we'd get x equals 1. So our restriction statement is going to be that x cannot equal 2, -1, or 1. So we'll include that in our final answer. Okay, so now remember our step 4, multiply all numerators by the LCD. So we've got the LCD noted up here, so we're going to multiply each of our numerators by x minus 2, x plus 1, x minus 1. X minus 2, x plus 1, x minus 1. And then we want to cancel anything that we can. Notice we've got an x minus 2 and an x minus 2. Let's cancel those. We've got an x plus 1 and an x plus 1. Let's cancel those. And I can't cancel this x minus 1, so we'll just bring that down. So we've got a 2x times x minus 1. Now over here, let's see what we can cancel. These both have an x minus 2, so that can go. And they both have an x minus 1, so those two can go. But we still have an x plus 1. So let's rewrite that. So we have a negative, don't forget that negative, that can be so easy to forget, a negative 4x times x plus 1. Now we're all ready for step 6, simplify the expression. So let's distribute. 2x times x is 2x squared. 2x times negative 1 is negative 2x. Negative 4x times x is negative 4x squared. And negative 4x times 1 is a negative 4x. We want to combine any like terms. So I see an x squared here and an x squared there. 2 minus 4 would give me a negative 2x squared. And a negative 2x minus 4x, well, that would give me a negative 6x. So now that we have this simplified as low as we can, remember our step 7. We throw our final answer over the original LCD. So x minus 2, x plus 1, x minus 1. We get that from right there. So this is your final answer. But we also want to remember that x cannot equal 2, negative 1, or 1. That was our restriction statement. Okay, let's look at one more together. We want to always start with step 1, so factor the denominators if possible. Both of these actually can be factored. Let's look at them individually. So in the first one, notice that's 2x minus 8. I have a GCF there of a positive 2. Both of those terms have a 2 in common that I can pull out. 2x divided by 2 is just an x, and a negative 8 divided by 2 is a negative 4. We factored the first denominator. Let's factor the second one. So we've got this x plus 1 up top. That one's a trinomial. Let's go ahead and build an x to help us do this factoring. A times c would be negative 8, and b would be negative 2. I know my signs would be a negative and a positive. Positive 2 minus 4. Those will multiply to give me negative 8 and add to give me negative 2. We can rewrite that as x plus 2, x minus 4. Our next step is find the LCD. What do the denominators have in common? What do they have different? Looking at this, they have in common x minus 4. And they have different a 2 and also an x plus 2. So here's how I'm going to write this. I'm going to put the 2 out front just because I think it looks better. You don't have to, but I just like to. And then we are going to put our x plus 2 in the back. Let's take a pause for a second to determine what would our restrictions be based on that LCD. So I like to come over here on the side and do my little restrictions bar. The first thing we're going to set equal to 0 is our 2. We've got 2 equals 0, and then we've got x minus 4 equals 0, and then we've got x plus 2 equals 0. The first one at 2 equals 0, that definitely looks a little funny, right? Here's the thing, 2 does not equal 0, which means actually that we ignore. For this one, we would want to add 4 to both sides, and we get x equals 4. And then for this one, we'd want to subtract 2 from each side, and we get x equals negative 2. So our restriction statement would be x cannot equal, we're ignoring that one, x cannot equal 4 or negative 2. Now that we have our restriction determined, we want to go back to this LCD. Remember, we multiply each of the numerators by the LCD, which I like to just do in that same step. So we got times 2, x minus 4, x plus 2. And then we'll do the same thing to this numerator, times 2, x minus 4, x plus 2. and let's cancel what we can. So notice in this one, I can cancel both the 2 and the 2. I can cancel the x minus 4 and the x minus 4, and I'm still left with this x plus 2. So let's write what we have, 3x times x plus 2. I can't cancel the 2 this time, but I can cancel the x minus 4, and I can cancel the x plus 2. So I just have this 2 of the LCD left. So we have to be very careful here. Okay, this is a negative, so we want to write that as a negative 2 times x plus 1. At this point, we want to simplify. So 3x times x is 3x squared. 3x times 2 is a positive 6x. Negative 2 times x is a negative 2x. And a negative 2 times 1 is a negative 2. This time we have 2 like terms in the center there. So we end up with a 3x squared. 6 minus 2 would give me a positive 4x. And then our minus 2 constant we just bring down. But we can't forget our final step, which is we take our simplified answer and we put it over the original LCD. 2x minus 4, x plus 2. And this is your simplified answer. But then we do want to note the restriction of x cannot equal 4 or negative 2. Okay, here's one for you guys to try. I will post the answers in the video description below. This has been Miss Math Tutorials.